with what I was planning to go over today. We'll see how far I get. Okay, so before I actually get into the information that I was planning to go over today, I have one more question for you. Tomorrow and next Wednesday are 2 more lab lectures. You have a choice. And majority rules. We either have these lab lectures in person, in which case they will be down in 105, and I will be doing things like I normally do in class. Or we have the lab lecture on Zoom, like we did last week. You have the choice whether it's in person or on Zoom. I'm going to be sitting right upstairs in my office one way or another for at least this week. But you've got a choice whether it's going to be in person or on Zoom. So the way this is going to work is we're going to, so that I don't miscount anybody, if you want it in person, you're going to stand up. And I'm going to count it. If you don't want it in person, you want it on Zoom. And folks, don't belittle anybody, whether they want it on Zoom or in person. It's just preferences.
This is going on right now. Do you want us to stand up?
I'm fixing to do it to it. Now, just like last week, whether it is in person or on Zoom, I will do a portion of the lecture. I will take a 10-15 minute break and I'll do the rest of the lecture. The big question is it in person or is it not? So all those that want it in person, stand up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 out of 48. So it is going to be on Zoom. It is rougher for some people to stay focused, I realize. But the good news is because of what we're fixing to start, it's going to be a little bit easier. Because number one, I'm going to lecture, and then I'm going to shoo you off to breakout rooms, and y'all are going to talk about how to do it and work some problems. And then we're going to come back together. So it is going to be a little bit more interactive than the last one. But it's still going to be a challenge. We're doing Lewis structures tomorrow. Do you want to revote? Okay. So it is going to be on Zoom. I can have a few people in my office if that makes a difference, but otherwise it's going to be on Zoom. Okay. So now let me get back to the topic at hand for the last 20 minutes. We're not going to get very far. So when we met on Thursday of last week, I ended the day talking about the polyatomic ions. There are something like 60 to 80 polyatomic ions that you need to know. So I was trying to go over the trends in hopes that that would help you memorize those polyatomic ions. But for many people, my experience is it's just going to be memory work. And while I wouldn't worry about it for tonight, I wouldn't worry about it for tomorrow night, after the test, I would start memorizing them. Because if you don't start immediately after the test, well, not immediately, but you know what I'm getting at. If you don't start after the test, when it comes to test 3, you're going to be in a world of hurt. I'm just speaking from experience and watching students test grades. So the trends in polyatomics. First of all, there is a trend for period 2, and that is the ones that end in ATE tend to have 3 oxygens. Whether that is borate, element 5, carbonate, element 6, nitrate, element 7, bicarbonate, all of those have 3 oxygens. Now, group 17 is a character all on its own. For period 3 through 7, if the polyatomic ion ends in ATE, that means there's going to be 4 oxygens. Whether that is silicate, phosphate, sulfate, arsenate, selenate, or tellurate, or whether that is chromate or permanganate. If they end in ATE, they tend to have 4 oxygens. Now for group 15 and 16, it's known as a family of 2. What that means is that there's 1 H and there's 1 I. And the difference between the ATE and the ITE is 1 oxygen. Group 17 is the oddball. It's a family of 4. Meaning there are 4 that have the element and an oxygen. And they literally go from, there's, when I say a family of 4, I'm talking about, there's going to be 2 ATEs and there's going to be 2 ITEs. As you go down in your family of 4, you drop 1 oxygen. So this one would have 4, 3, 2, 1. Now, because 2 ions can't have the exact same name, we add the prefix to the group 17 that has 4 oxygens. We add the prefix per. And for the group 17 that has only 1 oxygen, we add the prefix hypo. Now, there is another trend And I forgot to put this trend up here. So I'll put it in red. And that is for period 3 through 7. The polyatomic has the same charge as the element. What I mean by that is when I ask, what's the charge on phosphorus? It's a -3. What's the charge on phosphate? It's a -3. What's the charge on phosphite? It's a -3. If I ask, what's the charge on a chlorine? Element 17. Because it's in group 17, it's a -1. Well, what's the charge on perchlorate? -1. What's the charge on chlorate? -1. They all have the same charge. That is not true for period 2. But for period 3 on, it's true. Now, the last trend that I wanted to explain is the addition of hydrogen. Hydrogen as an ion carries a +1 charge. When combined with nonmetals. Now, the trend is that the charge on a polyatomic that contains hydrogen will be the sum of hydrogen's charge plus the polyatomic's charge. So when I combine hydrogen with phosphate, for example, then when I get to hydrogen phosphate, the charge I'm going to record is a +1 -3, that equals a -2. So this carries with it a 2- charge. If I combine 2 hydrogens, for example, with a phosphate to make H2PO4, well, the hydrogens carry total a +2 because each one has a +1. And then the charge on the phosphate is a -3 to equal a -1. So the charge on the dihydrogen phosphate is a -1. What that means is if you can memorize phosphate and understand hydrogen's impact on phosphate, you don't have to memorize hydrogen phosphate's polyatomic charge. The second thing is when naming, If you add one hydrogen, then you state hydrogen before the polyatomic name. So PO4 3 minus is phosphate. HPO4 2 minus is hydrogen phosphate. Basically, because we added hydrogen, we add the word hydrogen. If you add two hydrogens, you state that you added two hydrogens by including dihydrogen before the polyatomic name. So again, PO4 3 minus is phosphate. If I add two hydrogens to that, then it becomes dihydrogen phosphate. These are just trends in the polyatomic ions that can help you memorize the polyatomic ions. But for some, it's just going to be a matter of you memorizing. I can only give you so many trends to help you. But sometimes for people, it's just better off memorizing. Any questions about? Oh, it disappeared on me. It made something weird earlier and disappeared. Questions about polyatomics? Okay, what I really had hoped to get into today, but that's okay. If you feel more confident going into the test, that's more important at this point. But what I'd really hoped to get into today is our first glimpse into an ionic compound. An ionic compound is contains an ionic bond. An ionic bond is an electrostatic think magnetic attraction between a cation and an anion. I've already mentioned this once, but A cation is a positively charged ion. And an anion is a negatively charged ion. Ionic compounds are charge neutral. Meaning that the positive charges cancel out the negative charges. You'll be able to recognize an ionic compound because the formula begins with a metal or ammonium, and the name begins with the name of a metal or ammonium. Tomorrow, once we discuss the Lewis structure of neutral atoms of an element, we are going to discuss this loss of electrons by metals to form cations and the gain of electrons by nonmetals to form anions. I'm then going to illustrate this electrostatic attraction between the cation and the anion. After that, we're going to talk about covalent molecules and Lewis structures, which is going to be a much more in-depth story than the ionic. Now, because I did not get to what I had planned to today, gives me until after this afternoon to start the homework for next week, because there was a lot of naming of ionic compounds that you were, and formulas of ionic compounds that we are not going to be ready to do. So therefore, give me some time on that. Speaking of this afternoon, as a reminder, I do have office hours from 2:30 to 4:30 in 203C if you have any more questions before the exam. With that, I will see you on Zoom tomorrow.
scattered. It's not even funny. You told me what time you were getting back to your office, and I've already forgot.
I am getting back to my office at probably right around 12:30.
Okay, thank you. I have a question. You feel about like the calculation and stuff? You don't have to worry about sleep.
No.
Thank you.